Okay, now we are in section 7.2. In this section, we're going to take up the topic of arithmetic sequences and series. In the previous section, section 7.1, we introduced the idea of sequences and series. We mentioned a sequence is a function whose domain is the set of natural numbers. So now we're looking at arithmetic sequences and series. In other words, we're singling out a very specific kind of a sequence, namely arithmetic sequence. So let's see what I call the signature of an arithmetic sequence. An arithmetic sequence, and I'm just reading the definition that's in the book here, is simply a sequence where actually the consecutive terms means the terms that are in sequence. Consecutive means back to back. The difference between these terms is the same, it's fixed, called a common difference. So in other words, the word difference, that means I need to subtract, right? So if I subtract 5 from 9, I get a difference of 4. If I subtract 9 from 13, the next term, difference is common. Look at 21 minus 17. You see how we have a common difference between successive terms? Again, that's what I call the signature of an arithmetic sequence. The sequence is recognized as an arithmetic sequence. Now, of course, I said, the difference between two back-to-back terms is the same, but in the book, they kind of look at it from a different angle. They said you start with, for instance, 9, and 9 can be written as sum of 5 and a common difference 4. The next one, 13. That could be the previous term plus a common difference. 17, previous term plus a common difference. So the authors here, they choose to add a common difference to the previous term to get the next term. And that's what indeed they have in mind. Now, so indeed, this is how we find the common difference for an arithmetic sequence. You simply subtract the next term from the term before, and that would be the common difference. Now, you got to be careful here because we're talking about the difference, right? And subtraction is not commutative. So, for instance, a 5 minus 3, 3 minus 5. Those are two different answers, aren't they? They're not the same. So it does make a difference which term is being subtracted from which. So notice D is not A sub n minus A sub n minus 1. Because you're subtracting, A sub n plus 1. Because I'm subtracting the next term from the term prior. Okay, so that's not allowed. Okay. Just want to put that out there. Now, the formula for the nth term of an arithmetic sequence is given by what you're looking at here. The nth term, remember the nth term is the function that actually generates the, the sequence, right? The function generates the sequence. So that's what a formula is. In the case of arithmetic sequence, there is a formula, and we can use this formula that you see. The derivation of the formula is in the book, so I'm just going to skip over that part. It's not difficult to derive it, but we're just going to be users of it, not to derive it. But this is, again, the formula is called the nth term or the general term. The general term. That's what this formula is for. Now, the other idea in the section that we are interested in is, what if I want to add a few terms in the sequence? That will give me the series. So, for example, we did already earlier, remember, I added in the previous section, section 7.1, you can watch the video for that one, near the end of the video. I added the first 1,000 counting numbers. And of course, there I used the formulas we had, but we can actually do it using another method and using the formula for the nth partial sum. That's what this is called. S sub n, we call that the nth partial sum. I know you don't see the word partial here anywhere, but because we're looking at portion up to nth terms, right? So that's what we call partial. It's part of a whole infinite series, so it's partial. And again, the derivation of these are in the book, but I'm going to skip over it, and we're just going to do some exercises here together. Okay, so to do some exercises in this section, let's begin with, for instance, this series. Let's say in this example, I have a sequence whose terms are 3, -2, -7, -12, and so on. And we want to ask the question, does this sequence, is this an arithmetic sequence, right? Now, if you look at the difference, remember, the common difference is the next term minus the term before. So, for instance, if I look at the second minus first term, that's going to be -2 minus a 3, right? -2, and here's 3. Second minus first. So I'm going to get -5. What if I do the third minus the second? The third minus second is going to be -6 minus -2. Again, a -5. And just to do one more, so if I do A4 minus A3, this one is going to be -12 minus a -7, and again -5. You see, we have a common difference as we go from one term to the next term. Okay, so it looks like it is an arithmetic sequence that I just made up. This isn't a formal proof, by the way, that the sequence is arithmetic, but again, for what I want to do here, it suffices. Now, the common difference I already found, right? So here's the common difference. The common difference is going to be -5. Again, any two consecutive means back-to-back sequence could be used for this. Let's do another example. Okay, so for example, in this next example, suppose I give you the first term and I give you the common difference of an arithmetic sequence. Again, in this section, our focus is entirely arithmetic. So every sequence we write would be arithmetic. So suppose this is an arithmetic sequence whose first term is 5 and its common difference is -2. Okay. And let's say we want to write the first 5 terms. Okay. Now remember, a sub 2 is going to be, well, let me write it this way. If D is a sub 2 minus a sub 1, doesn't this mean a sub 2 is bring -a sub 1 to the other side? It's going to be a sub 1 plus a common difference, right? So what this tells me is the following. You give me the first term, I can give you the second term this way. I start with the term before, and then I'm going to add the common difference to it. So my second term is going to be 3. So far the sequence is 5 and then 3. How do I get the third term? Well, the third term is going to be the second term plus a common difference. That's a 3. The second term is 3 plus a common difference of -2, so you get 1. True? So this next one is 1. So you see how I'm going from term to term. In fact, for the next 2 terms, I don't need to write this formula again, do I? I'm just going to subtract 1 from each term as I go forward. So start with 5, subtract 2 from each term and go forward. So I start with first term 5, subtract 2, we get 3, subtract 2, we get 1, subtract 2, we get -1, subtract 2, we get -3, -5, so on and so forth. So there you go, that's going to be this sequence. So I just wrote the first 6 terms. Okay, that's the first 6 terms. Now, What if I want to find the general term? The general term. Remember, the formula for the general term is a sub n, a sub 1 plus n minus 1d. So I'm going to write this. This is the formula for the nth term. A sub n is a1 plus n minus 1 times common difference. So to use this formula, and this formula, by the way, what it does, this formula gives the function a sub n. It actually finds the formula that generates the sequence of numbers. So here's how this works. Let's say I make up a sequence 5, 7, 9, 11, 13, 15. See, those are, as long as they're equally spaced, this time the difference is 2. 7 minus 5 is 2. Let's say I want to find there you go. I want to find a sub n, the general term. So the general term is going to be, and I'm looking at this formula, it's going to be the first term plus n minus 1, because n is general. So I'm going to keep n minus 1 with n. Don't put a number there because we don't have a number to put in. And what is d here? D, do 7 minus 5, 2. Well, you can do 9 minus 7, doesn't matter, times 2. And there you go. Let's simplify this. 5 plus distribute from the right, 2 times n, 2 times 1. And now write it as 2n plus 3. And there you go. That is the function that actually generates the terms of the sequence. So try this. Let's try it. A sub 1. Now I'm looking at, again, remember, this is for any term. A sub 1, I got to go 2 times 1 plus 3. I'm looking at this function. That's 2 plus 3, 5. Aha. There you go. Let's look at a sub 2. What is a sub 2? You're looking at this function again. That's 2 times 2 plus 3. 4 and 3 makes 7. One more. A sub 3 is 2 times 3 plus 3. So that's 9. So you see how we are generating the terms of the sequence this way? And so that's what this is good for. Now suppose, here you go. Let's say I want to find the 1000th term in the sequence. The 1000th term is going to be 2 times 1000 plus 3. We're going into this formula. It's going to be 2000 plus 3, or 2003. Isn't that cool? That's the 1000th term. If we want, we can go the 1,000,000th term in the sequence, and so on and so forth with that one. Okay, so that's example of how we can use the general formula for general term. And so we did an example here where we actually found the function. See, that's what this formula does. Gives us the function that's capable of generating the terms of a sequence. Now, trying to do something now with these formulas. Okay, the formulas that you see here. So to do an example of this one, let's say I want to find this. There you go. In my next example, let's say I want to do find S sub 10. That means the sum of first 10 terms. The sum of the first 10 terms for, and my arithmetic sequence, let's say I'm going to make it 5, 9, 13, and so on and so forth. Okay, so in order to use the formula here, and the formula I'm using again, I'm going to use this one. N over 2, 2 times A1 and minus 1D. Okay, the sum, first the formula, S sub n is n over 2 times 2a1 plus n minus 1 common difference. So S sub 10, this time n is 10, isn't it? Why? Because that's the subscript on S. So that's going to be 10 halves times 2 times first term. First term is 5 plus n is 10. 10 minus 1. And what is the common difference? The common difference, subtract first from second. That's 9 minus 5, 4. Multiply by 4, the common difference. And this is going to be 5. That's 10 halves times 2 by 5 is 10 plus 10 minus 1, 9 by 4, 36. So it's going to be 5 times 46. True. And 5 times 46, what is that? 5 times 40, 230. And there you have it. Now notice we didn't write the first 10 terms. I didn't do this 5 plus 9 plus 13 plus 17 plus 21 plus 25 plus like that. But if we did, that should be 230 all the way up to the 10th term. Whatever that 10th term might be. Which we can find, by the way, S sub, not S sub 10, but A sub 10. You add these up, should equal to 230. Okay. Okay, let's try one other example here. In this next example now, suppose I want to evaluate this sum. How about the sum of I from 1 to 1,000. Remember, I did this again in my previous lecture on section 7.1 near the end. That's when I said, let's find exactly the same thing. This is 1 plus 2 plus plus 1,000. So in section 1, this is how we did it. Let me show you. We had a formula for this. Sigma I from 1 to n is n plus 1 over 2. We're not going to do it this way, but I just want to show you we've done this. 1,000 times 1,001 divided by 2, that gave us 500 times 1,001. And just like my video, that's what I showed, right? In sections. Again, 7.1, if you watch that video, that's what I have. So there you have it. Now, we want to do this using arithmetic series. Okay, so first of all, if I look at the series here, because the sequence is 1, 2, 3, 4, all the way up to 1,000, isn't it? So notice there's a common difference between these. D is 1, difference 1. So these terms are 1 unit apart. Okay, therefore, the sequence that you're looking at here comprises of an arithmetic sequence. All right, so let's write the specifics of this sequence. The first term starts with 1, and the common difference is 1. And just so you know that, let me put this a sub 1,000 is 1,000. I'm going to write this because I'm also going to use two formulas. I'm going to use both of these formulas to show you how they work. We've already seen this one. I'm going to show you how this other one works in just a few moments. Okay, so I identified the first term and the common difference, right? So I'm looking to find the sum of the first 1,000 terms of the series. Okay, and the formula that we had was this. It was n over 2. n over 2 times a1 plus n minus 1 times d, the common difference. So here's your 500. 2 times 1, 2, plus 1,000 minus 1 is 999. And 2 plus that makes 1,001. And check this out. Isn't that cool? They look the same now. So this is 500, 1,000, and 500, just as it was in previous section. Right? Two different approaches, two different ways. One using a formula. The other one is viewing the series as an arithmetic series. Now, the formula that I used here, we've seen earlier. This is the formula I used in the previous example. Now, let's take a look at this other formula we have, because I haven't shown you an example of this one. This formula is useful if you know the first and if you know the last term in the series, a1 and an. Okay, so let me do this. The formula says S sub n is n over 2 a1 plus a sub n. Okay, and we do. The first term is 1, the 1000th term is 1000. So S sub 1000. It's going to be 1000 over 2. First term is 1 plus the 1000th term is 1000. That gives me 500 times 1001, and look, exactly the same as there, same as here. The answer, of course, will not be any different. It's how we're doing it. It's different. And there you go. So this formula works as well. Okay. Now, one last thing I want to do is I want to show you that you can go, and we'll be done with this video. We can go from this form to that form very easily. Okay. Let me do that. And then we'll be done. So the form we have is n over 2, sum of the first term plus the nth term, right? Let me go back, and there you go. First term plus last term times n over 2. Now, and the formula for the nth term of an arithmetic series or sequence, doesn't matter, for an arithmetic, it's a single term, the nth term, the general term, we said was a1 plus n minus 1 common difference. Where is that one? Right in here. Right? That's the formula for the function, an arithmetic function. Therefore, I'm going to write this as a1 plus n minus 1 common difference. Now, plug in for a sub n into the first expression. So this is n halves a sub 1 plus a sub n, which is a sub 1, plus n minus 1 times the common difference. And change parentheses to brackets if you like. a1 and a1 are like terms, makes 2a1 plus n minus 1 common difference. And guess what? This formula is exactly what this one is, which is the one we just saw up here, right? Is this formula. So you can go from one to the other. Typically we use this one if you have the first and if you have the last term. If you don't, you usually use this one, the last one. But again, both of these are really the same, right? So either or would work. Okay, we're good. We're good to go. So I'm done with this section, and thank you for watching. And again, I'll hope to have you in another video. Goodbye.